Okay, welcome. This is our third part of our semester exam review, but really we're specializing in our quiz, pre-Christmas quiz over this material. 13, it's just going to be numbers 13 and 14, but 14's got quite a bit going on in it. Number 13, let f be a function given by, and it all seems simple, nice little cubic, and then we get this plus k at the end, where k is a constant, so k is just plus 6 minus 3. Good news is, if we're talking about derivatives here, k is going away, because the derivative of a constant is 0. So, the question says, on what intervals is f decreasing? But if we're speaking calculus talk, we would say f is decreasing when the calculus derivative, so y prime, is less than 0. And that would be a really good thing to put on an AP exam, because it gives it shows an understanding right off the bat. You miss the problem, you get some kind of credit for that. Saying, oh yeah, f is decreasing when the first derivative is 0. So our derivative is 3x squared minus 8x plus 5. Derivative of k would be 1, or would be 1 dk dx, but k is a constant here. The derivative of a constant is 0. So now I want to set this equal to 0. When I do, I'm going to factor this guy. I need factors of positive 15 that add up to be negative 8. Those are negative 5 and negative 3, so this does factor. And I'm going to get a 3x. To get a negative 3, I need a minus 1. 3x times x minus 1 times minus 5. That does it for us. So I get x equals 5/3 and 1. And now, if we were just calculus robots now, I would go y prime, set up my y prime chart. I would put in 1. I would put in 5/3. I'd say that's where the slopes are 0, or where the slope is 0 at those two instances. And then I'd put in 0, and I'd put 0 in, and I'd get, oh, it's positive 5. And I'd put in 2, something to the right of 5/3, and I'd get 12 minus 16, negative 4 plus 5, that's positive. Then I'd put in 1 1/3 maybe, and I'd get a negative here. But we got pre-calculus knowledge coming into this. This is a positive cubic that levels off twice. Positive cubics that level off twice look like this, don't they? Therefore, it goes up, it goes down, it goes up. It goes up, it goes down, it goes up. When does it go down? On the interval from 1 to 5/3. Okay? You good there? So don't be afraid to bring in things we already knew. I could have done this chart without substituting any values back in over here. Okay, on what interval is the graph concave up? Speak calculus to me. The graph is concave up when the second derivative, f double prime of x, is greater than 0. So f double prime, or y double prime, whichever the case may be, is the derivative of the derivative, 6x minus 8. And I want 6x minus 8 to be greater than 0. That happens when x is greater than 8/6 or 4/3, which is a decent answer, but it's not an interval. So my answer is 4/3 to infinity. Okay. All right. Now, I know. Let's forget about k for a minute. I know the shape of my curve looks something like this. What would k do to it? K would just raise the whole thing, lower the whole thing, but not change the shape at all. This is saying, find the value for k where f has 7 as a relative maximum. So if I know my curve looks something like this somewhere, I want this to be 7. But in part A, we already discovered our maximum occurs at 1. It goes up, it levels off, it comes down. So this is the 0.17. We want that to be the 0.17. Now, if k is not right, it won't be. We're gonna set k to make it, to force it to go through that point by just raising or lowering this function. So what do I get? Here's my original function. I'm going to rewrite it just so we can see it all at one point. We get y is x cubed minus 4x squared plus 5x plus k. So I want y to be 7 when x is 1. I'm not going to fumble through this. I get 1, I get minus 4, I get plus 5 equals k, so I get 7 equals 6 minus 4, 2 plus k, k is 5. Is that all right? Different but manageable. To be honest, once we've got that 1, if this said, find the value of k for which f has its maximum at 1 and its maximum 7, it's not even a calculus problem anymore. We used a little bit of calculus to find that 1 was the location of the max. Okay, 14. This, I will not put 14 on the quiz, but this definitely problem is almost exactly like this is on the final, and so it's, might as well take a look at it now. We're going to end up finding the second derivative of this, which is much like problem 2 on the last test that gave us the most challenges. So the derivative work, there's a lot going on in A here. In a 100-minute test, it's 14 questions long, no problem. In 50-minute quiz, this would be a problem. But I want to go through it. Find the acceleration. Well, the particle moves along the x-axis, so it can move right, left, change directions, whatever, but it's always moving right and left, so that its position at any time greater than or equal to 0 is given by the following function. X of t is 4t e to the negative t. That's negative t. I've looked at it a number of times and thought it was just negative 1. So acceleration is the what? Second derivative. So first derivative. X, you don't want to write too big here, I don't think. X prime of t. I want the plain old first function, 4t, times the derivative of the second. Well, e to the negatives, or e to the derivative of e to the wants to be e to the, but we have to take it times the inside derivative. Derivative of negative t is negative 1. Plus the derivative of the first function, just 4, times the plain old second. So that is negative 4t e to the negative t plus 4e to the negative t, which is okay, but its more useful form, as we know, is factored. And I can factor out, I'm going to factor out the negative as well. You don't have to factor out the negative. I can factor out a negative 4, and I can factor out an e to the negative t, and that leaves me with just a t here and a minus, because I factored out a negative, minus 1 there. Why is that useful? Or how is it useful? Well, I know when the first derivative, I know when velocity is 0 now. Velocity is 0 when t equals 1. Second derivative. So now decision time maybe. I guess I could have called this V and A. Now, do I want to find the second derivative from up here or from here? It seems like this would probably be worse. But finding the second derivative from this, I still have to use product rule here. And then some. And here, product rule, at least t minus 1's cooperative. I'm going to find the second derivative from this guy. So I want the plain old first, negative 4e to the negative t times the derivative of the second, that's just 1, plus the derivative of the first is negative 4 e to the, wants to be e to the negative t times the inside derivative, negative 1, times the just plain second. Any questions there? Cleaned it up. Negative 4e to the negative t. What's this one? Oh, is that right? Yeah, that's the derivative of t minus 1. I shouldn't even put it there. Got it. Plus negative, but another negative here. So that is plus 4e to the negative t times t minus 1. Let's factor that. I can take out a negative 4 again. I can take out an e to the negative t. I'm left with a 1. If I take out a negative, I've got a minus. And again, you can decide you want to take out positive 4 here, that's fine. I'm left with a minus, but the 4 is gone, the e to the negative t is gone, and I'm left with a t minus 1 here. Or negative 4e to the negative t times, this ultimately would be a 1 plus a 1, 2 minus t. Now that is just our acceleration function. We want the acceleration, or x double prime t, or x double prime of 0, excuse me. So I put 0 in here, and I get negative 4 e to the negative 0 times 2 minus 0, or I get negative 8. All that just for that. Good news is we're going to use some of the others after this. So we'll revisit that after Christmas break, prior to the final. Find the velocity of the particle when acceleration is 0. So I need to figure out, when is acceleration 0? Here's my acceleration. When is this function 0? So when is x double prime of t equal to 0? When t equals 2. I want my velocity when this happens, but this happens when t is 2, so I want my velocity at t is 2, so I want x prime of 2. And could have called that v. I probably should have called that v and a. So velocity at 2 is this guy, negative 4 e to the negative second times 2 minus 1, or negative 4 times 1, negative 4 on e squared. Okay. We did all the heavy lifting in A. Now C, find the total distance traveled from time equals 0 to 3. Here's the problem. I might be on this x-axis just moving all over the place and move miles and miles and miles and miles and end up right back near where I started it. But my total distance would be how far we moved right, how far we moved left, add them all together. So I need to know when I'm moving right, when I'm moving left. What do I want to find? If I switch from moving left to moving right, when do I make that switch? At a certain position, or at a certain velocity, or at a certain acceleration? Yep. I want velocity equals 0. I want to know when is velocity, or when is x prime of t equal to 0. Well, x prime of t is equal to 0. Here's x prime right here when t equals 1. Does it ever equal 0 again? No. So there's only one place I might be changing directions, and I might not even be changing directions. Maybe it's moving to the right and then moving to the right again. Moving to the right, pausing, moving to the right again. But it could be moving to the right, moving to the left, moving to the left, moving to the right. Okay? So I think I'm interested in finding what is x of 0. Where do I start? I think I'm interested in finding where am I at time 1. But is it clear? If the only time we pause is at t equals 1, from 0 to 3, then from 0 to 1 I must be going the same direction the whole time. So if I start at 7 and end at 11, I've went 4. Okay. And I also want to find x of, do I want to find x of 2? Don't really need to. X of 3 matters though, doesn't it? So I must have gone one direction for a second, paused, and then gone 2 more seconds in either one of the 2 directions. So if I could find the distance from 0 to 1 and the distance from 1 to 3 and add them up, I got it. Okay, so I'm going to rewrite x down here just so we can see it. X of t is 4t e to the negative second. So I put 0 in and I get 0 times, wait a minute. X of t is. This isn't negative second, this is negative t. Excuse me. I put 0 in, I get 4 times 0, e to the 0th. That is 4 times 0, 0. That's nice. I put in 1, I get 4 times 1, 4 on e. And I put in 3, I get 4 times 3, 12 on e to the 3rd. So I'm not even, you could go ahead and analyze and figure out when we're moving right, when we're moving left. But I know that if I call this D1, my first trip, I went 4 on E, whatever that is. My second trip, if I call this D2, let's say I was at 3 and I ended up at 8. I traveled 5. What if I was at 8 and I ended up at 3? I traveled 5. Can't I just subtract these and just make sure my answer is positive? So I could represent that with absolute value 4 on E minus 12 on E cubed. That makes sense? Now you could find out, you could go to your calculator and find out which one of these is bigger and never work with absolute value. Okay. So our total distance equals 4e plus absolute value 4 on E minus 12 on E cubed. Or approximately, let's see, do I have that up here? Does this sound right? I had a key out. This is 2.346. Is that what the key said for this? Is that all right? So again, 14 feel a little bit guilty about it. Well, I'd feel completely guilty about giving this in a 50-minute quiz unless there was a lot fewer problems. So that problem won't be on there tomorrow. Other problems that won't be on tomorrow's would be number 12. This is a problem we should be really good at. It just takes too long for us at this time. That'll be on the final, problem like that. And then the other problem that's on your sheet that would not be on there is H, I believe it is. We're not going to have an inverse trig function on this one, but anything else is viable. Okay. All right, hope that's helpful.